we're digging down 1 meter, and we're going to pull 1 meter of material out of here. We're going to put a layer of rock, which is about 3/10 of a meter deep, 2/10 of a meter of Selecto, and then 1/2 meter of sand. Back in 1998, Hurricane Mitch blew through Honduras, wiped out hundreds of roadways, and this happened to be one of them. It had a small culvert in it that wasn't able to handle the capacity of Hurricane Mitch, the water or the rain that came through with the hurricane, and it actually overtopped the pipe and eroded the channel, and essentially just cut right through the roadway and cut both sides of this community apart from each other. And they haven't had a roadway since then, so it's been 13 years without a road through here. We divided the project up into 3 task areas. We have the riprap, both upstream and downstream of the pipe area, and that's Damien DiVittorio is in charge of that. We have the excavation and the compaction and the roadway fill, which is Alan Ertel's responsibility, and then the actual placement of the reinforced concrete pipe, which is Courtney Miller's responsibility. And so they're the task leaders. The biggest thing was we needed a group of students to help us with the project, and we were really short on students who didn't have other projects going on at the same time. Well, this year just happened to coincide that both SIUC and SIUE were looking for a project to work on, and as you've seen or are going to see on this project, that it's big. It's got a lot of different elements to it and a lot of work, and we really need a lot of bodies working on it. So everything just kind of came together this year for us to be able to work on it. So last year on our assessment trip, we did all of our survey, did all of our data collection for the area, and we have spent the last year now designing this project, planning and designing this project. We've met monthly all the way from last August up to this August, and we pushed the time limits, but we got it done and got the project design done and got it approved by EWB, and now we're in implementation stage.
Okay, right now we just finished putting the geotextile fabric in on the downstream side of the culvert. We put the fabric 2 layers, 3 layers up at the front, and now we're covering it with 2 or 3 inches of a material they have here called Selecto. We're going to put 2 or 3 inches of Selecto along the fabric just to protect it, and then we're going to start placing the riprap down here. And the riprap are about 50-pound rocks. The whole idea of the fabric is to help with erosion prevention and mitigation. So that's the idea. And we don't want to tear it, because if you get holes in the fabric underneath and water starts running underneath, and will wash the soil underneath away. So that's the idea. As you can see, the water's flowing on top of the fabric. This is great. This is what we want. It's working beautiful.
I'm in charge of all of the excavation and base material preparation for the pipe installation. And then after Courtney actually gets the pipes placed and they get mortared in place, then I'm going to be responsible for getting all the backfill and the road preparation to restore the road surface.
Deej, what are you doing?
I'm spreading sand. Trying to make a nice good base layer for the pipes to go on. Yeah, 6 inches of sand ain't easy to get to.
You having fun?
It's a blast.
So these pipes, they weren't really designed for the flow rate, and actually in Honduras they don't even have enough data to figure out what size pipe they needed. So we actually had to use rainfall data from Hawaii, because they have a similar temperature and climate zone. So we actually used that rainfall data And using the topographic survey and the area we're working in and the volume of rainfall, we're able to determine how much water will be going through this area. And then we used an American concrete pipe design manual to go through and size it. And here in Honduras, they have 3 types of concrete pipe. There's type 1, type 2, and type 3. And so I think for our purposes, type 1 is actually enough, but we went ahead and went with a type 2 pipe and checked it structurally with the overburden pressure once we build the roadway and make sure structurally it was safe. So in order to properly set this pipe, we ordered some rigging materials from the US, from suppliers that I work with for my normal job. And just based on the weight and the dimensions of the pipe, we were able to figure out a method of moving these pipes and setting them in place and pulling the connection in without damaging the pipes. So basically I've been looking at rigging procedures to set this pipe properly and safely.
So the way this works is that when we start pulling against that pipe, the pressure on this will wedge this piece of wood into the pipe. And that way it'll kind of be a brace, it'll pull that section into this section, in theory.
Right now I'm checking the slope of this pipe. We need about a 7-degree grade going up through the trench. So what we did is we took the rise and run over a 4-foot length. This is a 4-foot level, 5 5/8" stub right here. So to place it on top of your concrete pipe, this should be level.
Cubic meters.
So right now,
you have to get it 3 feet above the pipe.
we aren't quite level, so I have to bring this end up.
And then that counts for, like
to find out
15 cubic
how far we
meters.
need to go. So it looks like we need about 1 inch of soil.
And I'll do a quantity on that.
Yeah, about 1 inch on the upstream end to get the perfect grade.
Yeah, because what originally destroyed the crossing in the first place in '98 was Hurricane Mitch. And we assumed a 500-year flood in which the water comes probably up to about here on the pipe. And so if you kind of look downstream, you can see about where the water line is going to be, which is right about at the top of the rocks. The problem that they had before is that the crossing just upstream from us here was simply an earthen dam with a 15-inch pipe that's about this big. So when you get a 500-year flow coming through there, it comes screaming out of there like a giant fire hose. And it causes a lot of erosion, you start to lose your banks and things like this. So putting these pipes in, we want to return it to a more natural condition, a more natural controlled condition that will be able to stand these high flows that they get every so often down here.
on all sides of the reinforced concrete pipe. There, in the middle, and on the other side. It helps with the strength of the reinforced concrete piping before we backfill to make the road with sand.
It's definitely been a great experience, especially getting to know all the students too. I mean, they've just been amazing, and I haven't heard one complaint from anyone, even though they're being worked harder than I would have ever imagined that we would have to work here this week.
One of the things that's really great about this project is there's a lot of community involvement. So the town of Pimienta actually put forth $8,000, which is a lot of money for them. I mean, these workers are getting paid $7.50 a day to work with us, and they put down $8,000 for this project because it was something they really wanted. And that's what ultimately is going to make this project successful.